Today I have you reviewing some fraction and some decimal rules with our guest teacher. So I'm giving you two riddles here. The first one is called Gone Fishing. And if you notice on the side, we are reviewing fraction division. So the nice thing about these riddles, and my goal for you today, is to, yes, follow these steps. In fact, if you want to jot them down somewhere on your paper, that's not a bad idea. And secondly, to make sure that you're finding your answers as final answers down in the riddle. It's self-checking, so you can tell if something's going right or wrong for yourself, which is kind of an awesome opportunity. So if it's not going well, you know to ask a good question of your table partner, or maybe of our guest teacher, or maybe it's something you need to go home and practice a little bit tonight to make sure that you're back on track. So notice also, there's a name line on here and a date line. It also helps me if you give me your hour. So if you give me your hour, it makes life a little bit faster when I'm going in the grade book. If things get shuffled a little bit, I can always find you quickly. So please help me out. For some reason, as soon as students see riddles, they like to kind of start digging in and solving the riddle, and they forget to give me their name, date, and hour. So we don't want that to happen to you. The other thing I will say to you is you are currently sworn to secrecy. You and your table partner, as you work on the riddles today, should probably raise your right hand and repeat after me. So this is an opportunity to raise your right hand, okay, and repeat after me. This is your right hand, by the way. So I solemnly swear that as I complete my riddle, I will show my work, I will do my best, keeping a math focus, and I promise not to reveal the funny haha until after told to do so. And I understand that that will not be until the next block with Mrs. Schumann. So my riddle is a tool for me to know how well I'm doing in math. Okay, you can remove your right hands. Oh, don't take them off, just you can set them down. And you can stop repeating after me, of course. And I want you to notice this is actually homework assignment number 1. It says it on the back board there for you in your planner information. That means this is going to be graded. And in order to get full credit, you need to attach all of your work. Now you might say, Mrs. Schumann, you didn't attach your work. You showed me examples right on the paper. That is true, I did. But that leaves you now the opportunity to see an example right there and now dig in with the other examples on your own workspace, okay? Your own opportunity to show me your work on attached paper. If it's not attached and I can't read what's happening here, you're going to lose points or just have to redo it. So kind of a friendly reminder, show your work, but attach it on separate paper. I'm going to show you, well, first of all, we'll take a look at problem E. This is a friendly reminder. This KCF comes also from my rules up top. It says, hey, during this process, I can look to simplify a fraction maybe, but I definitely have to keep, change, flip. That second step I have to do. And then I might look for cross simplification, where I use the same rule in a numerator and denominator. Some people call that butterfly method. Some people call that Band-Aid method. I call it cross divide or cross simplify. And next, we can multiply straight across and see if our answer needs to be turned into a mixed number, if the elephant is smushing the chicken, or if we can simplify in some way. All right, so if you take a look at the first example, this KCF is a hint to you. We need to keep, change, flip. And I showed you this cross simplifying with those loops happening there. So that's what we're going to start with part D, problem D. Will you copy this on your paper for me? And not only that, your paper probably should already have a title, Gone Fishing. It probably should also have a name, date, and hour, because sometimes you forget to staple things. And I need to know this belongs to you. All right, here we go. Problem D. First of all, I want you to copy down exactly what you see the way it's written. So we're going to take that 1/2 and we're going to divide by 3/4. So this would be on line paper if I had it. So this is just my example of how I expect you to show your work. Well, this is a division of fractions problem. So up at the top, they give me some steps. Now this is not on your paper, so it wouldn't be a bad idea to jot this on your lines. In fact, if you want the guest teacher to kind of pause this video for you, you can say, guest teacher, please pause, right? And if we put this on pause, you might copy down these steps right on your line paper or right here on your riddle so that you have them and you'll remember what to do in order. All right, so the first thing says, can I simplify a fraction? There's a question mark after that, meaning take a look. Does 1/2 simplify? Not really. 1 is as low as you can go. Kind of like the limbo. Take a look at 3/4. Can you simplify this fraction? No, it looks like it's in simplest form. So the next thing I want you to look for today is the keep, change, flip. I'm going to label that KCF. or freeze change flip, up to you. What that means is I keep the first fraction the way it's written. I change from division to multiplication. And a flip means a reciprocal. When I rewrite this as 4/3. If I go back up to those steps, it says, okay, after you keep change flip, you could cross simplify if possible. Remember to use the same rule. So is there any cross simplifying you can show me today? Oh, on this problem, I notice this 2 and this 4, they share a common factor. What could I divide 2 and 4 nicely by to make the numbers a little simpler? Oh, 2. 2 goes into both. So let's talk about that. 2 goes into 4 twice. So I show it on the outside here to make sure I grab the new numerator in a minute. And 2 goes into 2 just once. So I show that on the outside of my cross simplifying. What about this 1 and 3? Can I cross simplify? 1 is as low as you can go. It's like the limbo. So I guess we're ready to move to the next step. Multiply straight across. That means 1 times 2 is 2, and 1 times 3 is 3. It's like I get an answer of 2/3. Now, hold up. Step 5, what does it say? Make a mixed number? No way. The elephant is not smushing the chicken. In fact, the chicken's going for a ride. This is good. This is fine. No mixed number needed. And then it says, what about simplifying? Oh, 2/3, can it be simplified? The answer is no. This is your final answer. What I would love to see you do, if you could really wow and amaze me, because we are now 6th graders, halfway through the year, soon to be 7th graders, would be to take your answer and transfer it over onto your worksheet. So this 2/3 I should see sitting right next to problem D, cha-ching, and is also labeled on your workspace. And the second thing you need to do, maybe the third thing, fifth thing, I don't know, move down to the bottom of the riddle, make sure you can find 2/3, and if it's there, call it letter D. We're going to figure out why Batman couldn't go bass fishing. There must be some reason for that. Again, you're sworn to secrecy. Don't you dare tell anyone besides your table partner, and then we will talk more about that the next time I see you. All right, let's take a look at letter F. So I'm just grabbing a few kind of random problems here, things that I could see while I'm working with you in the video, so that you can get some good examples down. So I'm going to copy down the problem exactly like it's shown, 2/3 divided by 4/12. And I want to then refer to these steps, which maybe you have copied on your paper already. Maybe we need to pause the video and make sure you have them down. They say, check to see if I can simplify a fraction. There's a question mark. See if you can. Take a look at 2/3. Can you simplify that at all? No, 2/3 as low as you can go. Take a look at 4/12. Can we simplify this at all? The answer is yes. I could divide both 4 and 12 by 4. I could make these numbers smaller right now. 4 goes into 4 one time, and 4 goes into 12 3 times. Notice I'm writing those numbers really large, kind of on the outside here, so that I know when I rewrite this, it's not 4, it's not 12 anymore, it's 1/3, or 1/3. So let's go ahead and do that. I'm going to rewrite and call this 2/3 divided by 1/3. Is there any other simplifying I can do at this moment? No, because I need to do a keep, change, flip. That has to happen before you cross simplify. So keep the 2/3. It's frozen, burr, it stays the same. We change to multiplication and we flip or show the reciprocal of 1/3. So that becomes 3/1. All right, I did that keep, change, flip business. Take a look at number 3. Can I cross simplify? If I can, I need to use the same rule. I noticed something. 2 and 1, well, that 1's as low as you can go. It's like the limbo. But this 3 and this 3, 1 in the numerator, 1 in the denominator, tells me I can simplify. They both divide by 3. I'm going to show that rule. And I know that 3 goes into 3 one time, so I write that on the outside. I make sure that you can see that this is my new numerator. And then 3 divided by 3 again is 1 in my denominator. I show that on the outside so that you can tell this is your new denominator. And if I go back up to my rules, it says go ahead and multiply straight across. So be careful, it's not 2 times 3 anymore. It's 2 times 1 gets me 2. And 1 times 1 gets me 1. Now you can look all over the place, but you're not going to see that in your riddle. Did we do something wrong? I've seen some of you try to flip this. Are you allowed to make a flip or a reciprocal in your answer? The answer is no. But what you could do is you could say, hey, that 2 is written over 1. That's kind of like saying, what is 2 divided by 1? Like an improper fraction. Well, 1 goes into 2 twice, because 2 times 1 is 2, and when you subtract, there's nothing left. If you were to write this as the ring of fire, or as a mixed number, you'd get 2 and 0 wholes. But really, that's the same as just 2. Do some checking for me. Remember that whenever I have a whole number, I could write it over 1, so I could take that 1 away and write it as just a whole number. Is 2 found somewhere in your riddle? I hope so, because you're going to call it letter F. And not only that, you're going to transfer your answers. So what does that mean? You take your answer and you jot it on your worksheet. The answer here is 2. All right, things are going pretty well, right? Let's take a look at one more. Let's take a look at letter H before we flip our paper over and try the other side. So letter H, notice I'm labeling my workspace. I'm showing Mrs. Schumann where to find problem H in case she needs to do some looking and figure out what I'm doing right or wrong. So I'm going to copy down the problem as it's given. 5/6 divided by 7/12. All right, well, the steps say, can I simplify the fraction? And the answer is, well, 5/6 is simplified. 7/12 is simplified. So the answer is no. So I'll go to step 2. Can I keep, change, flip? The answer is yes, because this is a division problem. We don't do division of fractions. We really turn them into multiplications, don't we? So let's try that. K, C, F. Keep the 5/6. Change to multiplication. And flip or show the reciprocal. It's going to look like 12/7. All right, step 2, check. Step 3, can I cross simplify? If so, I have to use the same rule. Well, I can draw some loops around here and take a look. 2, 5, and 7 cross simplify. They both divide by 1. That won't change them a whole lot, will it? So I guess that wasn't necessary, but what about the 6 and 12? Can I go the other way? Oh yeah, 6 and 12 are both even. They both divide by 2. But we're at the auction now. 2 going once, going twice. Ooh, 3. 3 going once, going twice. 3 goes into 6 and 12. That's pretty good. Going once, going twice. Ooh, freeze. 6. 6 goes into both. We try to find the largest number or the greatest common factor to go into both, because then our numbers get so much smaller and nicer to work with. So let's talk about this. Does 6 go into 12? Yes, twice. So we show that 2 on the outside. Does 6 go into 6? The answer is yes, 1 time. So we show that on the outside. If I've done all the cross simplifying I can, rule number 3, check, is done. So I get to multiply straight across. That's what rule number 4 reminds me to do. So be careful. It's not 5 times 12 anymore. That would be a really big number, like 60. Instead, it's 5 times 2, which gets me 10. And it's 1 times 7, which gets me 7. And I'd love to look for that answer in my riddle to see if I'm doing okay, but it's not there. Oh no, did I do something wrong? Oh no, you did not. You need to look at step 5. Can I get a mixed number? Is the elephant smushing the chicken? Yes, it is. In fact, 10 is too big for the denominator. So what that means is, just like in the example I gave you on your worksheet already, when I had 6 over 4, the elephant smushing the chicken, I took 6 and divided by 4. The numerator divided by the denominator. An elephant split by a chicken. Oh dear, that sounds awful. Let me go ahead and show that on this problem. 10 is going to be divided by 7. Well, does 7 go into 1? No. But it goes into 10 once, so I show it in the quotient. 1 times 7 is actually 7, and when you subtract, you're left with 3. I don't have to go to decimal land. We're working with fractions. We're in fraction land. How fun. And I can write this as a mixed number. So take a look. How many wholes did I get? How many entire groups did I make? The answer is 1 whole group. 1 group. And how much left over? 3 left over in my numerator. And the last thing I run into is my denominator. Notice it stayed the same. It was 7ths, it's still 7ths. All right, can I simplify this anymore? The answer is no. And notice the chickens on the elephant, things are good. If you take a look, this should be an answer down in your riddle. And I'm also going to transfer my answer. I'm going to make sure that you can see my answer in my on my worksheet as well as in my workspace, in both places. So that way I can really follow where you are and where your work is coming from. All right, I think that's enough for gone fishing. Again, you're sworn to secrecy. Please, only you and your table partner are allowed to know the funny haha, and we will talk about it when I see you next. But we are ready to move on to the second side of your homework today, because you're asked to do something else for review. You're asked to multiply some decimals. So I have to see if I can get us there. Upside down won't work too well. Sideways not so great. Here we go. If you take a look, this riddle is called, Why Are Restaurants So Dangerous? I'm going to move these rules out of the way. If you notice, this is a different set of rules, isn't it? This time I'm multiplying decimals. So I wrote out some steps for you. You may want to ask the guest teacher to put this on pause. That wouldn't be a bad idea. because you might want to copy down exactly what the steps tell you to do. This is again in your notes. I hope you remember working on our hawk map, which really gave you the steps on what to do. But in case you don't have that handy, or in case you just want a little shortcut to look at, these 3 steps could go right on this worksheet where it says, why are restaurants so dangerous? All right. I gave you a couple examples on here, and I showed you how to build that bank, and I tried to show you what to do. So number 4 has already been done for us. But I want to take a quick minute and make sure that you're okay with these other ideas. So let's just take number 1. I'm going to kind of move my box up here so I have some room to work. And if we were to read the riddle, it says, do each exercise below. If the exercise involves money, round to the nearest cent. Oh, we might have to do some rounding, make it look like money, money, money. Find your answer in the appropriate answer column, and notice the 2 letters next to it. Write these letters in the 2 boxes above the exercise number at the bottom of the page. So earlier, I figured out that my answer, 2,121, got me the letters of H-I down in the riddle. So that's why those are recorded for you. Let's look at number 1. This is a great example of money. And oh darn, I just did a terrible thing for you. I forgot to show you how to label this paper. So could we call this restaurants? That's kind of the title. We'll call it restaurants. Good shortcut. It's a restaurants riddle. Your name, date, and hour should be on this paper also. Maybe you're working on a separate sheet. Maybe it's on the back side. I don't know, but I have to be able to tell what you're working on. So restaurants riddle, name, date, and hour in case it comes unattached, which we hope never happens. Problem number 1, let's take a look. This is decimal multiplication. I'm going to take $2.59 and I'm going to multiply by 0 6/10. Do I need to line up the decimal? No way. This is decimal multiplication. So let's look at our rules. Multiply, ignore the decimal. Well, I'm good at ignoring things. I'll ignore the decimals. All right, so 6 times 9 is 54. You can use your multiplication charts today, but we don't need calculators. So challenge yourself. Use those charts a little bit if you're getting stuck on your facts. I think we can do it. All right, 9 times 6, 54. Keep the 4, regroup the 5. 6 times 5 is 30. 30 plus 5 more is 35. Keep the 5, regroup the 3. Notice I'm ignoring decimals. You should be too. 6 times 2, well that gets me 12 plus 3 more. 13, 14, 15. Looks like I'll get 15 here. Well, that's a mighty big number. Who knew that if I took approximately $2 times 6/10 that I would end up with $1,554? Oh, you won't. In fact, when I multiply by a decimal, oftentimes the numbers get smaller. This doesn't make much sense to me. So, please remember to go up to your rules. It tells you to build a bank, the decimal bank. We need to talk about how many jumps you see in your problem. So, with the first number, I noticed that the decimal's over 2 places. 2 places. They divided by 10 twice. You don't need to know that, but you do need to know that there are 2 jumps or hops there. Well, take a look at the second number. How many jumps, hops, or place values are behind the decimal? Just 1. So, what does it say to do? Total the bank. Find the total. That really means add them up. And that'll give you the total hops to take in my answer. All right, what's 2 hops plus 1 hop? 3 hops, y'all, right? So here I want to start at the back of the number, and I'm jumping how many times? 3. 1, 2, 3. Notice every hop just hops over 1 place value at a time. Hopefully we see this answer sitting somewhere out there. But you know what? It doesn't look much like money. Not yet. So this would be a good time to maybe use your riddle. Look over here at the answers for numbers 1 through 8 and see if we see something kind of similar. Oh, I see something really close. In fact, it's sitting right here with the letters H and T. Is it possible that I could round this to $1.55? Would it make sense? Oh, we go to the cents or the hundredths place, and he looks to his neighbor. Okay, we always look to the right when we're rounding, if you remember that from maybe 3rd and 4th grade. 5 or more, raise the score. 4 or less, let it rest. That's sometimes the rhyme I use. I'm sure your teachers taught you other ones about climbing vines and hitting floors, but this is the one that works for me. 5 or more, raise the score. No, that's not a 5 back here. So 4 or less? Yes, it is. Let it rest. This is going to round down. It's closer to $1.55 than $1.56 is really what I'm saying here. This should be boxed in, circled, framed, somehow shown on your workspace, on your lined paper. And remember, we transfer our answers now.
So I'm going to come over here and show you that I got $1.55. It worked out. I did kind of circle that ahead of time, didn't I? And I was thinking to myself, will it work? And I figured out the reasoning for it. When I rounded, it absolutely rounds to $1.55. All right, I'm going to take a look at another one that we can see here. So how about number 5? You should not be erasing your work, but remember, I need a little more space, so I'm kind of taking advantage of my eraser at this moment. And I'm going to copy down number 5 just because I happen to see it here. I'm going to copy down the problem exactly like I see it on my lined paper, and I am not lining up decimals. Perhaps because step 1 says ignore the decimal. Just multiply. Just do it. Okay, so let's just do it. What's 4 times 2? 8, hopefully. And 4 times 9, check your facts if you need to, but it's 36. We'll keep the 6, regroup the 3. Be careful, this has been a big error lately. 4 times 0 is 0 plus 3 more. Oh, just 3. You're done with this place value. You want to move over. I have a second digit to multiply by. I think we need to call Bob. There he is. We are ready now. I can move to the 9 and say, what's 9 times 2? The answer is 18. Keep the 8, regroup the 1. What's 9 times 9? That's 81, plus 1 more makes 82. I'll keep the 2 and regroup the 8. 9 times 0, this is where it could go wrong. 9 times 0 is actually 0. 0 times anything is 0, right? And I need to add 8 more. So 0 plus 8 is 8. I'm ready to add my 2 products together and see what happens. So I've ignored the decimal the entire time. You're doing well. And I remembered Bob because there were multiple digits to multiply by. What's 8 plus Bob? 8. What's 6 and 8? 14. Keep the 4. Regroup that 1. 3 and 2 is 5, plus 1 more makes 6. And 8 plus maybe nothing if you need to put Bob's girlfriend in here, or just a placeholder, you can. 8 plus 0 is 8. Whoa, this got really big really quick. 8,000 something. 9 times a little tiny number like 92 thousandths got me 8,000 something. This makes no sense. So we need to go to our rules, which say, after you ignore the decimal, build a bank. All right, decimal bank. So the bank reminds me how many places behind the decimal. 1, 2, 3 for the first number. 3 hops, 3 jumps, or they divided by 10 3 times. All right, take a look at the next number. How many hops or place values behind the decimal? Just 1. All right, I built my bank. Step 3, total the bank. Total it up, add it up. We love to save things in a bank. And we say 3 plus 1 gets us 4. 4 hops is what I need to take in my answer. So I'm using those steps the whole way through. First, I ignore the decimal while I multiply. Next, I build my bank. I total it up, and now I take 4 hops. Where should I start hopping from? I hope you remember that we treat this like a whole number. We start at the back, and we get ready to hop towards the front. 4 hops. 1, 2, 3, 4. This is the correct decimal location. Now I have to see if I can find that answer over here to make sure things are going well. I see some things similar. And this looks pretty close. Oh, the numbers are off a little bit. This looks a lot like something over here. Notice there are 4 digits behind the decimal, and it starts with 0.86. I see something like that here. Here's the problem. There's a 0 in front. Is this okay? If I put a 0 here, would that be an okay thing to see? 0 and 8,648 10,000ths. In fact, that's my answer. I'll circle it in, also circle it on here so that I don't try to choose it again, and I'll transfer my answer so Mrs. Schumann can tell I got a good answer here. Nice. Your answer has been transferred, and down in your riddle, find number 5 and call it the letters N-I. N-I, that's an I, by the way, not an L. N-I. All right, we've got the right idea happening here. We're following those steps the whole way through, and I hope that they're on your paper somewhere to help you out. I'm going to fast forward to something that looks a little bit tricky. It is really a review from long ago, but I'm guessing we haven't seen it in a while. So why don't we take a peek at, say, number 9? Number 9 on your workspace. Let's copy down exactly what we see. 0 and 1500ths times 0 and 1500ths times 10. Oh my goodness, holy multiplication Batman. Oh, Batman was on the other side, wasn't he? Well, regardless, I noticed something. I'm multiplying 3 numbers. That's pretty tough to do. If ever I was given 3 numbers, if they're whole numbers, I just take 2 at a time and multiply. That's kind of what I want to do here. Couldn't I take these 2 numbers and multiply, see what I get? And then multiply by 10 in a minute? I think that'll work. So let's give it a try. What I'm going to do here is maybe show some work off to the side. I don't know, see what we get. 0 and 1500ths times 0 and 1500ths. The decimal lined up. Oh no, am I doomed? No, just remember you're multiplying. Be careful. It sometimes happens that way, not often though. And I follow my steps. Multiply by ignoring the decimal. All right, everybody, ignore the decimal. 5 times 5 is actually 25. We keep the 5, regroup the 2. 5 times 1 is 5 plus 2 more makes 6, 7. There we go. And 5 times 0, if you want to show it, is a 0 up front. It doesn't really affect too much, but that's good to know. All right, I'm done with this 5. Sometimes I say X's and O's. Here we go. Or, hello, Bob, I need your help. Sometimes when we do these X's and O's, you might want to remember to cross off anything that was regrouped up top. It just might make things a little bit safer for you. So let's go ahead and multiply. Now I have this 1 times 5 is 5, and it's lined up right underneath the same place value, isn't it? Now I have 1 times 1 is 1, and 1 times 0, if I want to show it, is 0 out front. I know some of you like to use the 0 and multiply times all of that. I don't know if it's required, because what would I get when I multiply 0 times anything? A bunch of zeros. If you want to show it, it's going to end up looking something like, well, 2 X's, 2 O's, 2 Bobs, or Bob and his girlfriend, Betsy. And then 0 times everything up there is going to get me a lot more zeros. I'm not sure if this line of work is necessary. In fact, even though it's nice to see Bob and Betsy and all their friends, I think we might not need it. So let's talk. What's 5 plus 0, or Bob? 5. 7 plus 5 is 12. We'll keep a 2, regroup the 1. Hard to see that there, but it's there. 1 plus 0 is 1, plus 1 more makes 2. And 0 plus nothing, 0. Now, don't forget, we're following the steps. We multiplied, we ignored the decimal. Perfect. But now we get to find that decimal bank. Build the bank, it says. So off to the side, we're going to talk about the bank and how many places we see behind each decimal. So in the first number, I see 1, 2 jumps. 2 in the bank. Behind the next number, I see 1, 2 jumps again. Now don't fall into the trap. Don't you dare bring down the decimal. Those would be bad words on a project like this. That's only when we're adding or subtracting decimals. So instead, we count the bank, count the total jumps. Looks like 2 plus 2 is 4. I need 4 hops in my answer. So remember, where do we start? Well, we treat it like a whole number where the decimal's at the back, and we jump 4 times heading to the left or to the front of the number. 1, 2, 3, 4. Now, some of you might not have had a 0 sitting in here. You still need to jump a 4th time and put your decimal in the correct home. Then you might come back and fill it with a placeholder, and that's okay to do. Well, we're going to try to find this answer somewhere up there. And honestly, I think I might have to scroll a little bit because I can't see it, and I hope we're right. So let me dig in here a little bit. That was not looking too good for me. Oh, I noticed something. It says answers 9 through 16 are on this side. Oh, the answer's not there. Why not? I hope you're having an alert moment. I hope you're saying in your head, alert, alert, caution, caution, the answer's not there, something went wrong. It did. There's more to be done. Do you see how this is not a final answer? This is just a part of the answer. This gets me going, oops, this gets me going in the right direction. So I could copy down that 0 and 0 and 225, tenths, hundredths, thousandths, 10,000ths. Yikes. And I still have to multiply it times 10. Notice I haven't done that last step yet. Oh, there's one more move to make. That's why the answer wasn't in there. I love these riddles. They help me remember to do an extra step when needed. All right, we need some more lined paper here. And the good news is I have a little space over here. So I guess I'm going to show you this idea right over here. Do I need to line up the decimals? No, because we're multiplying. So we ignore the decimals. We go right through our steps another time. Multiply, ignore the decimals. Well, 0 times 5 is 0. 0 times 2 is 0. 0 times 2 is 0. If you want to keep going, 0 times 0 is 0. And 0 times 0 out front is 0. Well, that was fun. X's and O's. Here comes Bob. Here we go. Now I can move to the next place value. I say 1 times 5 is 5, 1 times 2 is 2, 1 times 2 is 2, 1 times 0 is 0, 1 times 0 is 0. Those extra zeros up front might not be necessary, but not a bad idea to show them in case you want to be safe. And we can add these up and see what we get. 0 and Bob, still 0. 0 and 5, 5. 0 plus 2, 2. 0 plus 2, 2 again. And some extra zeros up front. Don't know if we need to show them, but I'll put them there for now. Whoa. This is interesting. It kind of looks similar to the numbers I had a minute ago. But I noticed something. I ignored the decimal, and it's time for us to walk through those steps. It says, build a bank. We get to do it again. We need a second bank for a second part of the problem. So how many decimal places are behind the first number? 4 hops. Uh-oh, I don't see the decimal in 10. Do you remember where it is? Any whole number. Does the decimal go in front? In the middle? At the back? Oh, whole numbers. Decimal at the back. This doesn't even have to save any places for the decimal, does it? So we'll write 0 here. 0 jumps to get to that decimal. It's already there at the back. So we add these together to get a total number of hops. That's what step 3 says. Total up the bank. Well, 4 hops. So let's take this and see what we can do. We start at the back and hop 4 times. 1, 2, 3, 4. I'm getting an answer that looks something like this. It looks kind of similar to the other one I had, but notice the decimals moved a little bit. Because I multiplied by 10, that decimal made this number a little bit bigger. All right, so let's see if we can find this now. It should be sitting somewhere in problem numbers 9 through 16. I see something kind of like it. Take a look. Do you see anything with that 0.225 in it? Oh, what about this? I'll circle it and I'll ask you. Think this is good? Well, this looks a little bit different than my answer, doesn't it? I have an extra 0 up front. I have an extra 0 at the back. But does that have the same value? Yeah, it does. So number 9, we found a good answer. Down in the riddle, you're going to add the letters EN. And on your actual worksheet, we need to take a quick minute and make sure that we record our answer there. So number 9 at the back, I should see you copy down. Again, this was the answer we found. It's on your work and it also goes on your final answer. 0.225. That one was definitely more challenging. There were 2 steps. I had to multiply the first 2 numbers before I could multiply that last number. So sometimes there are multiple steps. All right, I see that happening for number 10. You're going to have to multiply the first 2 numbers and then multiply it by 100. I see that happening for number 12. Multiply the first 2 numbers and then remember to multiply whatever you get times the last number or $55 there. But I see something funny coming at us here in a second. In fact, number 13 and number 14 look kind of special to me because these aren't just multiplications. There's something else happening in here. There's an addition in one and a subtraction in the other. Well, if you remember addition and subtraction rules with decimals, they are a little bit different. So number 13, let's take a look. Before I can take 1,000 times whatever is here, I need to think about PEMDAS. I hope you've heard that before. Please excuse my dear Aunt Sally. Well, the P and please tells me to take care of the parentheses. PEMDAS. So there are parentheses. Let's wipe them out first. Well, this is adding decimals. Do you remember a rule for adding decimals? Your decimals have to be aligned. So I stack those decimals right on top of each other. The first number I wrote first. The second number I'll just put here and fill in the numbers around the decimal. There's a 0 in front and then a 033 behind it. 033. You might want to show me some placeholders so that I don't get confused. Oops, that 0 got a little wild, but it'll work. And now, remember, go back. It tells you to add. Make sure we're copying down the right part of the problem. We're getting this right. All right, I can go ahead and add these pieces. 0 plus 3 is 3, and 0 plus 3 is 3. 3 plus 0 is 3. 3 plus 0 is 3. And let's talk about the decimal. What happens when you add and subtract decimals? This is different. This is what we used to do. We bring the decimal down. Awesome. You can do digging all day, but I hope you don't find this answer because there's one more thing to do. After you get this, after you took care of your parentheses, what did it tell me to do? Multiply by 1,000. All right, so I need to copy this over. I'm going to take the 3 and 333 thousandths, tenths, hundredths, thousandths, times 1,000. Am I lining up decimals? No. Well, that's weird. I did a second ago because I was adding. And I will on another problem when I'm subtracting. But I don't need to because I'm multiplying at this moment. Look at all these zeros that are going to happen. I hope some of you have learned kind of that those zeros are going to, however many zeros are at the back, that's how many zeros I get in the answer. It's kind of like saying, do some thinking off to the side here. 7 times 10? 70. I get 1 0 at the back. How about 7 times 100? Oh, 700. 100, 200, 300, 400, 500, 600, 700. I get 2 zeros at the back. How about this? 1,000 times 7? Oh, 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000. I had 3 zeros. I get 3 zeros. Huh. So what happens in this problem? I should get 3 zeros. Bob is actually a triplet today. Looks like I'm gonna get 1, 2, 3 zeros, and then I multiply 1 times everything up here. 1 times 3 is 3. 1 times this next 3 is 3. 1 times this next 3 is 3 again, and 1 times the 3 out front is 3. This is an enormous number, but we're not done with it. This is decimal multiplication. We multiplied, we ignored the bank. Now we get to build, oops, we multiplied, we ignored the decimal, sorry. Now we get to build the bank. So let's try that. Well, how many places over is the first decimal? The answer would be 3. How many places over is the decimal in 1,000? Well, if you don't see the decimal, it's at the back. It's already a whole number. That requires 0 jumps, no places to save. So if we total it up, 3 hops. Notice this is different. I need to build a bank when I multiply, but when I add and subtract, I line up the decimals. So let's hop 1, 2, 3 times and find a final answer. That's a little bit difficult to read. If you remember, I might want to move out 3 places and put a comma. Looks like I'm getting 3,333. Let's see if we can find this answer somewhere on our riddle choices. So over here, answers 9 through 16. Ooh, right here. Are you serious? This means the same thing? Absolutely. If I put a couple zeros behind a decimal here, I would still have the exact same value. So RU is the answer to the riddle for number 13. And we're going to transfer over our answers. We're going to call this 3,333. Those extra place values could make it challenging today. So just be careful. Make sure that you're using the bank when we multiply, but not if we add and subtract. I'm going to show you one more. I'm not sure if you need it. Maybe the sub has decided, hey, enough with the videos. I'm just going to let you guys work, which isn't a bad idea. So number 14, the last one I'll look at, and then I think you're going to be ready to roll. I forgot to copy down the problem on the last one, so I want to copy it down this time and do a little bit better job of modeling for you. All right. Hey, this is another PEMDAS problem, not PANDAS. PANDAS don't have problems. What I mean is there are parentheses. So I need to take care of those first. So I want to figure out what this gets me. Off to the side here, I might show you I want 9, and I want to take away 1.6. Well, where's the decimal in 9? Because I have to line up my decimals to add or subtract. I hope I remember 9's a whole number. So the decimal in 1.6 will go right underneath it. There's a 1 in front of the decimal, so I show a 1 in front of this decimal. There's a 6 behind the decimal, so I show a 6 behind this decimal. Might be helpful to see a place value here. Bob, you're back. Now be careful, this one is actually subtraction. So that's again why I lined up my decimals, so I can subtract. Well, I start on the right side here, and I say, what's 0 take away 6? That's not easy to do without a little regroup. So Bob, I'll get you a little bit more here. Don't worry, I'll go to the neighbors. Knock, knock. Can I borrow something? We leave 9 with 8, and the 10 that we get from him turns Bob into 10. Well, next I have 10 take away 6, which is 7, 8, 9, 10, 4. And 8 take away 1 is 7. Now be careful, that decimal, I was ignoring it, but I'm not sure if that's a good idea when I add and subtract. Think back to the last problem. Look back at your work. What did we say you needed to do? We lined up our decimal because we need to bring the decimal down. 7.4. 7 and 4 tenths. Is that an answer?
Ew, it's not. Why not?
Because there's another step. The 7 4/10 is part of the problem, but I still need to multiply times 100. So let's see here. Do you remember that when I multiply by 100, I get a couple extra zeros at the end of my answer? Notice I'm not lining up decimals because this is multiplication. So I'm going to end up with 2 zeros at the back of my answer. And 1 times 4 is 4, and 1 times 7 is 7. And if you want to show the other steps in there, you're welcome to, but I hope that this is kind of an understanding that when I multiply by 100, we get 2 zeros. If I multiply by 10, I get 1 zero. If I multiply by 1,000, I get 3 zeros, and so on. Well, this isn't an answer over there either. And that's good because I haven't completed the bank. Well, let's build a bank. I'm just going to call it B for bank right now. How many hops in the first number? Just 1. How many hops to make this 100? None. 100 is a whole number. So how many total jumps or hops will we make? Just 1 hop. Starting at the back of our number, we jump 1 hop, 1 time towards the front. And I'm looking for an answer of 740.0. If I were to show you what I got here, I could just rewrite that as 740, I bet. Let's do some checking. Can we find that over here somewhere? 740. Oh, I see it. Looks okay. Looks CK. Looks like that's a good answer. So number 14, we'll copy down, transfer our answer, call it 740. And down at the bottom in your riddle, oh, I can see the 14 sitting right here. So this is kind of handy. I'll fill in C and a K. All right. I know that this can be challenging because we're relying a little bit on a lot of skills, right? We're relying a little bit on your past experience with subtracting and adding some decimals. We're also using maybe 3 numbers to multiply, so just take 2 at a time if needed. Don't forget, when multiplying, build a bank. All right, your assignment is to really finish this. It's for homework. It's due the next time I see you, and I want you to give your best. Show all of your work on some lined paper. Try to be as organized as possible and transfer those answers. That means I will see an answer for each of these. If you get stuck, I would say put a question mark next to that problem, whatever it might be, and that's something that we can talk about when I see you again. There should be no blank papers here, no blank problems. We try them all, and then we jot down maybe a question mark if there's something we're wondering.